And in this lecture we'll answer two questions. The first question, we find out the radius of this circle, and in the second question, we find out the area of this green shape. So we start with the first question. In the drawing, we have a circle. From this common some point A, we have tangent AEP and tangent AQ to this circle. And we also have tangent BC that is tangent to this circle at this point. So we define the point of tendency of tangent BC with this circle. This point is point M. So tangent BC equals to 14 units in its length. Know that line segment AC equals to 18 units in its length. This is line segment AEB, it is equals to 16 units in its length. Again, our task is to find out the radius of this circle. So first of all, we define the center of this circle. This point is point O. We define the radius of this circle as R. R is the radius that you're looking for in this question. In the next step, we'll join points O and Q together by a straight line. Point O is the center of the circle, point Q is the point of the circle itself. Actually, point Q is the point of tendency of tangent AQ with this circle. So point O is the center of the circle, point Q is the point of the circle itself, therefore OQ is the radius of this circle, that equals to R according to our definition. The radius OQ is equals to R, the radius OQ is 1 to point Q, that is the point of tendency of tangent AQ with this circle. And whenever you have a radius that is 1 to the point of tendency, then tangent AQ will be perpendicular to the radius QO. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees inside according to rule 1. Point P is the point of tendency of tangent AP with this circle. So we join points O and P together by a straight line. OP is of course the radius of this circle, that is equals to R. The radius of OP is equals to R. The radius OP is 1 to point P, that is the point of tendency of tangent AP with this circle. Whenever your radius is 1 to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to the same rule, rule 1. We define the length of this short line segment VB as X. So here you can implement also rule 2. We can pick rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing, we have a circle. This is the common standpoint point P. From this common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule, all two are equal to each other in their lengths. That is to say, PA equals to PB. So we can implement rule 2 in our drawing. In our drawing, if you focus on this common standpoint point B, for this common standpoint point B, we have two tangents to this circle, tangent PB and tangent BM. According to rule 2, they're equal to each other. That is to say, BP equals to BM. But BP equals to X, therefore BM must also equal to X in itself, according to rule 2. What is the left of this? Shows that this is a nice MC. MC in total equals to BC minus BM. And again, MC equals to BC minus BM. The left of the short line side MC is equal to BC minus BM. So MC equals to BC, BC is 14, minus BM, BM is X. So if you know that the MC line side means MC equals to 14 minus X units in itself. The next step is focus on this kind of standpoint, point C. From this kind of standpoint, point C, we have two tangents to this again, tangent CQ and tangent CM. According to rule 2, they are equal to each other. That is to say CQ equals to CM. But CM equals to 14 on 6, therefore CQ must be also equal to 14 on 6 units in itself, according to rule 2. The next step, focus on this kind of point, point A. From this kind of standpoint, point A, we have two tangents to this again, tangent AP and tangent AQ. According to rule 2, they are equal to each other. That is to say, AP equals to AQ. So, it is done. If you hold on that according to rule 2, according to rule 2, tangent AP equals to tangent AQ in itself. Tangent AP equals to tangent AQ. Tangent AB equals in total to PB that is X plus BA that is 16. So in total PA equals to X plus 16 or 16 plus X. So AP equals to 16 plus X. And it is equals to AQ. The result of tangent AQ in total it is equals to QC that is 14 minus X plus CA that is 18. So in total QA equals to 14 minus X plus 18. So here we have 14 plus 18 is 32 minus X. So total this expression equals to 42 minus X. Those two sides of the equation are equal to each other. That is to say, 16 minus X equals to 32 minus X. Therefore, 16 plus X equals to 32, again 16 plus X equals to 32 minus X. So two sides of the equation are equal to each other. That is to say, 16 plus X equals to 32 minus X. Here we subtract 16 from this equation. So in this side of the equation, 16 we get cancelled, and we have to leave X. But on the other side of the equation, we have 32 minus 16 is 16 minus X. So to that, if you found out that X equals to 16 minus X, here we add X to this equation, we get that X plus X is 2X equals to X plus X is 0, so we have to leave 16 in this side of the equation. So in total, if you found out that 2X equals to 16, here we divide this equation by 2, so we get that X equals to 16 over 2 is 8. So X equals to 8 units in its name. This is line side PB or tangent PB is equals to X and X equals to 8. So PB equals to 8. Likewise, BM also equals to x and x equals to 8. Here we have MC equals to 14 over 6. That is to say MC equals to 14 minus 8, that is 6. So MC equals to 6 units in its length. Likewise, QC is equals to 14 minus 6 is 14 minus 8, that is 6. So in the next step, we will join points A and O together by a straight line. By joining points A and O, we can deduce two right triangles. This is the upper right triangle APO, and this is the lower right triangle OQA. So what is the area of the big quadrilateral APOQ? The area of this big quadrilateral APOQ is equal to now this big quadrilateral APOQ is equal to the sum of the areas of those two components that the big quadrilateral APOQ consists of. That is to say, it is equal to the area of this first component that quadrilateral APOQ consists of, is the area of this right upper triangle APO. Plus the area of this second component that the big quadrilateral APOQ consists of, is the area of this right triangle AOQ. Beginning in total, we found out that the area of the big quadrilateral APOQ equals to the sum of the areas of those two components that it consists of. This equals to the area of the first component that quadrilateral APOQ consists of, usually the area of this right upper triangle APO, plus the area of this second component that the big quadrilateral APOQ consists of, usually the area of this lower right triangle AOQ. So the area of the big quadrilateral APOQ equals to the area of triangle APO plus the area of the right triangle AOQ. What is the area of the upper right triangle APO? The area of this upper right triangle APO equals to the base AP times the height PO over 2. Equals to the base AP times the height PO over 2. That's the area of the right triangle AOQ. The area of this right lower triangle AOQ is equal to the base AQ times the height OQ over 2. Okay, again, the area of this right lower triangle AOQ in total is equal to the base AQ times the height OQ over 2. AP in total equals to 16 plus 8, that is 24, times PO, that is R over 2. So total the area of this upper right triangle APO equals to 24R over 2. Plus the area of the lower right triangle AOQ is equals to AQ is 18 plus 6, that is 24, times OQ, that is R over 2. So total the area of this right lower triangle AOQ equals to 24R over 2. So the area of the big quadrangle AOQ equals to 24R over 2, that is actually 12R, plus 24R over 2, that is plus 12R. So 12R plus 12R is 24R. So total, if you found out that according to the first method of calculation, the area of the big quadrangle APOQ is equal to 24R squared in size. And again, the area of this big quadrangle APOQ according to the first method of calculation is equal to 24R squared in size. In the next step, I will delete this straight line AO. And we will join points O and M together by straight line. Point M is the point of tendency of the missing with this circle. So point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of this circle, is equal to R. The radius OM is equal to R, the radius OM is 1 to point M, that is the point of tendency of tangent BC with this circle. And whenever your radius is 1 to the point of tendency, then tangent BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this angle equals to 90 degrees inside, and this angle is also equals to 90 degrees inside according to all 1. In the next step, we will join points O and B together by straight line. Likewise, we will join points O and C together by straight line. So actually, by doing those constructions, we can do 4 right angles. 1, 2, 3, 4. So in the next step, we calculate the area of each of them separately, and then we add all the rest together. So what is the area of this first right triangle OPB? The area of this first right triangle OPB equals to the base PB, that is 8, times the height PO, that is R over 2. So total, the area of this right front triangle OPB equals to 8R over 2. 8R over 2 is 4R. What is the area of this right triangle OMB? The area of this right triangle OMB equals to the base MB, that is 8, times the height MO, that is R over 2. So in total, the area of this small right triangle OMB equals to 8R over 2. 8R over 2 is also 4R. 4R squared in size. What is the area of this right triangle OMC. The area of this right triangle OMC is equal to the base MC, that is 6, times the height MO, that is also over 2. So total the area of this right triangle OMC equals to 6R over 2. 6R over 2 is 3R. Plus the area of this right triangle OQC. The area of this right triangle OQC equals to the base QC, that is 6, times the height QO, that is R over 2. So total the area of this right triangle OQC equals to 6R over 2. 6R over 2 is 3R. So in total, the area of this, those 4 right triangles, 1, 2, 3, 4, is equal to 4R plus 4R is 8R, 8R plus 8R is 11R, and R plus 3R is 4R, 14R. So total the sum of the areas of those all 4 right triangles is equal to 14R squared in size. Therefore, the area of this big quadrangle APOQ according to the second rule of calculation the area of the upper right triangle and the area of the upper right quadrangle APOQ according to the second method of calculation is equal to the sum of the areas of those 4 right, the sum of the areas of this of those 4 right triangles is actually 14R plus the area of this missing triangle ABC. And again, according to the second rule of calculation, the area of the big quadrangle APOQ equals to the sum of the areas of those 4 right triangles, this is actually 14R, plus the area of this missing right triangle ABC. So what is the area of this triangle ABC? Actually, we have a special formula for the area of any triangle. Here, triangle ABC could be any triangle. The area of triangle ABC that could be any triangle is as follows. It's equal to the square root of S times S minus A times S minus B times S minus C. This equation, S is the semi-perimeter of the triangle, that is area that we are looking for. This is the semi-perimeter. What is the semi-perimeter? The semi-perimeter is the perimeter over 2. And the perimeter of any triangle is equal to the sum of its 3 side lengths. In our case, the perimeter of this triangle ABC equals to 16 plus 14 plus 18. And if we divide the perimeter by 2, we get the same perimeter of our triangle ABC. Or triangle ABC. So in total, the perimeter of triangle ABC equals to 16 plus 14 is 30, and 30 plus 18 is 48. 48 over 2 is 24. So in total, we found out that those 2 sides of the equation are equal to each other. That is to say, the semi-perimeter of our triangle ABC is equal to 24 units in its length. So the semi-perimeter S equals to 24 units. A, B, and C in this equation is the side length of triangle ABC, or the side length of the triangle that is area that we're looking for. In our case, we choose A is 16, we choose B in this equation, here is 14, this is B and B is 14, and we choose C in this equation, this side C8 is equal to 18. So actually have all the data that is needed in order to find out the area of this green triangle, triangle ABC. We just have to put the data for triangle ABC inside this general formula for the area of green triangle. This way we find out the area of this triangle, triangle ABC. So we'll do it now and get that the area of our green triangle ABC is equal to the square root of S is 24 times S minus A. S minus A is 24 minus 16 times S minus B. S minus B is 24 minus 14 times S minus C. S minus C is 24 minus 18. So today we found out that the area of our green triangle ABC is equal to the square root of 24 times 24 minus 16. 24 minus 16 is 8 times 24 minus 14. 24 minus 14 is 10 times 24 minus 18. 24 minus 18 is 8. 24 minus 18 is 6. So today we found out that the area of this green triangle ABC is equal to the square root of 24 times 8 times 10 times 6. Actually, the value of this expression in total is equal to 107.33 square root in size. So the area of the big green triangle ABC is equal to 107.33 square root in size. And again, the area of this triangle ABC is equal to 107.33 square root in size. So actually found out that the area of the big quadrangle AP of Q according to the second method of calculation is equal to 14R. That is the sum of the areas of those four small rectangles plus the area of this triangle ABC. That is 107.33 square units in its size. So it is known again, according to the second method of calculation, the area of this big quadrangle AP or Q is equal to the sum of the areas of those four small rectangles. It's actually 14R plus the area of this green triangle ABC. This is really 107.33 square units in size. So according to the second method of calculation, the area of quadrangle AP of Q equals to 14R plus 107.33. Well, according to the first method of calculation, we only found out that the area of the same quadrangle AP of Q equal to 24 R square units in size. And again, we will find out that only the first method of calculation, the area of the big quadrangle APOQ is equal to 24 r square root inside. So we have two different equations from the for the area of the same quadrangle APOQ. Therefore, we get equation 3 that says that the area of the big quadrangle APOQ, according to the first method of calculation, must be equal to the area of the same quadrangle APOQ, according to the second method of calculation. So the area of the big quadrangle APOQ, according to the first method of calculation, is equal to 24r. It must be equal to the area of the same quadrangle APOQ, according to the second method of calculation, is equal to 14r plus 107.33. So according to the equation 3, I should find out that 24r equals to 14r plus 107.33. Here we'll subtract 14r from this equation 3. And we get that 24r minus 14r is 10r. In the other side of the equation we have 14r plus 14r is 0, so we left only 107.33 in the other side of this equation 3. So in total we found out that 10r equals to 107.33. Here we divide this equation by 10. So we get that the radius r of this circle, that is the radius that we are looking for in this question, equal to 107.33 over 10, that's actually 10.733 units in its length. And again, the area, the radius of this circle, that is the radius that we are looking for in this question, is equal to 10.733 units in its length. So finish to answer the first question. In the next step, I will present you the second question and answer the second question of this lecture. In the second question, our task is to find out the area of this ring shape. But again, the second question, our task is to find out the area of this ring shape. So in the drawing, we have 3 semicircles. This is the biggest semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have also in the drawing this rectangle. And according to what is given as a question, the area of this rectangle is equal to 4 square inches in size, and finally we have this quarter circle. Again, our task is to find out the area of this ring shape. So first of all, we find the length of this rectangle. This side is x, and the width of this rectangle, this side is y. The length times x times the width y equals to 4, because it is given as a question that the area of this rectangle is equals to 4. So x times y equals to 4. But you also know that the opposite sides of a rectangle are equal to each other. So in this rectangle, those two opposite sides are equal to each other. But this side equals to y, therefore the opposite side here must be also equal to y according to the rule that I mentioned. This is a quarter circle. Those two sides, the above the area of this quarter circle, and therefore they are equal to each other in their lengths. So, but this is the radius equals to y, therefore the other radius must be also equal to y. Actually, from the drawing, you can see that here this line segment is greater than this line segment, but it is the problem with the drawing itself. You would assume that those two on the of this quarter circle are equal to each other, so each of them is equal to y. It is actually very difficult to draw this drawing exactly like it should be. Therefore, you should assume that those two line segments are both the area of the quarter circle, therefore they are equal to each other, each of them is equal to y. The problem is with the drawing itself. So, the diameter of this biggest semicircle is equal to x plus y, and therefore the radius is x plus y over 2. So the radius of this biggest semicircle is equal to x plus y over 2 units in itself. So the radius of the biggest semicircle is equal to x plus y over 2 units in its length. What is the radius of this medium semicircle? The radius of the medium semicircle equals to the diameter x over 2. So the radius of the medium semicircle is equal to x over 2 units in its length. And finally, the radius of this smallest semicircle is equal to the diameter y over 2. So it is y over 2 units in its length. The radius of the smallest semicircle is equal to y over 2 units in its length. Our test is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the area of this green shape in total it is equal to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. So until now, the area of this green shape, that is the area that we are looking for in this question, it is equal to in total to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. We already found out that the radius of this biggest semicircle is equal to x plus y over 2 units in incident. Once the area of the medium semicircle, once the area of the medium semicircle, we already found out that the radius of this medium semicircle equals to x over 2 units in incident. Once the area of the smaller semicircle, we already found out that the radius of this smallest semicircle equals to y over 2 units in incident. So what is the area of the biggest semicircle? Actually, we know that the area of any semicircle it is equal to pi times the radius of the semicircle squared over 2. So it is pi over 2 times the radius of this biggest semicircle. The radius of this biggest semicircle squared is equal to x plus y over 2 squared. So in total, we found out that the area of this biggest semicircle equals to pi over 2 times x plus y over 2 squared. Once the area of this medium semicircle. The area of this medium semicircle equals to pi times the radius of this biggest semicircle squared is x over 2 squared divided by 2. So in total, we found out that the area of the medium semicircle equals to pi over 2 times x over 2 squared. Once the area of the smallest semicircle equals to pi times the radius of this smallest semicircle squared is actually y over 2 squared divided by 2. So the value of this expression in total is equal to the area of the green shape, that is the area that we're looking for in this question. So in the next step, we just simplify those three expressions. Okay, again, we simplify those three expressions, and this way we get the area of the green shape. So here we have pi over 2 times x plus y over 2 squared. X plus y over 2 squared equals to x plus y squared over 2 squared. 2 squared is 4. Minus pi over 2. X over 2 squared equals to x squared over 4. Minus pi over 2 times y over 2 squared. Y over 2 squared equals to y squared over 4. Here we have 2 times 4, that is 8. Here we also have 2 times 4, that is 8. And here also we have 2 times 4, that is 8. So in the next step, we take 8 as a common factor out of those three expressions. So in the denominator we have 8. That is taken as a common factor out of those three expressions. Well, in the denominator of this expression we have pi times x plus y squared. Here we have minus pi times x squared in the numerator. Here we have minus pi y squared in the numerator of this expression. We continue to simplify this expression. Here we have pi times x plus y squared. In the numerator we have 8, and here we have pi times x plus y squared. So it is pi times x plus y squared. X plus y squared equals to x squared plus y squared plus 2 times x times y minus pi x squared minus pi y squared. We'll open the brackets of this expression and get that the area of the green shape in total is equal to pi y squared. It is pi x squared plus pi y squared plus 2 pi xy. Here we have minus pi x squared minus pi y squared divided by 8. So in total we found out that the area of the green shape, that is the area that we are looking for in this question, is equal to this expression. So pi x squared minus pi x squared is 0. Those two expressions will get cancelled. pi y squared minus pi y squared is also 0. So in the denominator we have left only 2 pi xy. Here we have 8. Here we have 2. 8 is second factor. So here it is 8. Not 2 but 8. So here we divide both the numerator and the denominator of this expression by 2. 2 over 2 is 1, so in the numerator we left only pi xy. When the denominator we have 8 over 2 is 4. So if you found out that they have this green shape is equal to pi xy over 4. So it is pi over 4 times xy. Now we found out that xy equals to 4, so we solve xy this equation by 4. So it is pi over 4 and xy is 4. We have 4 in the numerator, so 4 we get cancelled and left only with pi. So to them we should find out that they are this green shape, that is the area that we are looking for this question. Is equal to pi squared is in size. Again, if you don't know that the area of this green shape, that is the area that we are looking for this question, is equal to pi squared is in size. So we finished to answer the second question. And the next step, so the next step, that is to say, I repeat on the solution of the first question, and then I repeat on the solution of this second question. In the first question, our task was to find out the radius of this circle. So in the drawing, we have a circle. From this connection point A, we have tangent AP and tangent AQ to this circle, and we also have the third tangent BC is equal to 14 units in its length. So we define the point of tendency of tangent BC with this circle. This point is point M. AB, line segment AB equals to 16 units in itself, line segment AC equals to 18 units in itself. Again, our test is to find out the radius of this circle. So as I mentioned, we define the point of tendency of tangent BC with this circle. This point is point M. We define the center of this circle, this point is point O. We define the radius of this circle, that is the radius that we're looking for this equation, SR. Radius is R. Point Q is the point of tendency of tangent AQ with this circle. So we join points O and Q together by side line. Point O is the center of this circle, point Q is the point of the circle itself, therefore OQ is the radius of this circle, is equals to R. The radius of OQ is equals to R. The radius of OQ is drawn to point Q, that is the point of tendency of tangent AQ with this circle. Whenever your radius that is drawn to the point of tendency, then tangent AQ will be perpendicular to the radius QO according to rule 1. If AQ is perpendicular to QO, it means that this angle equals to 90 degrees and its side according to rule 1. Point P is the point of tendency of tangent AP with this circle. So we join points O and P together by side line. OP is the radius of this circle, is equals to R. The radius of P is equals to R. The radius of P is drawn to point P, that is the point of tendency of tangent AP with this circle. Whenever you have a radius that is drawn to the point of tendency, then tangent AP will be perpendicular to the radius PO. If AP is perpendicular to PO, it means that this angle equals to 90 degrees according to the same rule, rule 1. So here we implemented also rule 2 in our drawing. We define the graph of this tangent BP as X. So multiplication rule 2. According to rule 2, the lengths of two tangents from a common standpoint to a circle are equal. In the drawing we have a circle. This is the common standpoint point P. From this common standpoint point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is to say, PA equals to PB. You can implement rule 2 in our drawing, because in our drawing, if you focus on this and this common standpoint point B, from this common standpoint point B, we have two tangents to this circle, tangent BP and tangent BM. And according to rule 2, they are equal to each other. That is to say, BP equals to BM. But BP equals to X according to our definition, therefore BM must also equal to X according to rule 2. So what is the law for this missing element MC? MC equals to BC minus BM. MC equals to BC minus BM. That is to say, MC equals to BC, that is 14, minus BM, that is X. So in total, if you found out that MC equals to 14 minus X, you can see its length. The next step, we focus at this common standpoint point C. From this common standpoint point C, we have two tangents to this circle, tangent CM and tangent CQ. And according to rule 2, they are equal to each other. That is to say, CM equals to CQ. But we only found out that CM equals to 14 minus X, therefore CQ must be also equal to 14 minus X according to rule 2. The next step, we focus at this common standpoint point A. From this common standpoint point A, we have two tangents to this circle. Two tangents to this circle, tangent AP and tangent AQ. And according to rule 2, they are equal to each other. That is to say, AP equals to AQ. And again, according to rule 2, tangent AB equals to tangent AQ in its length. AP in total equals to 16 plus X. AP equals to 16 plus X and it equals to AQ. AQ in total equals to 18 plus 14 minus X. And again, AQ in total equals to 18 plus 14 minus X. AQ in total equals to 18 plus 14 minus X. Here, 14 plus 18 is 32. So this expression in total equals to 32 minus X. So those two sides of the equation are equal to each other. That is to say, 16 plus X is equals to 32 minus X. Here, we subtract 16 from this equation, so here 16 will get cancelled, left only with X in this side of the equation. And on the other side of the equation, we have 32 minus 16 is 16. So in total, the other side of this side of the equation, we have 16 minus X, or X equals to 16 minus X. Here we added X to this equation, so here we have another, in this side of the equation we have X plus X, that is 2X, equals to X plus X is 0, so left only with 16 in this side of the equation. So in total we found out that 2X equals to 16, here we divided the equation by 2 and found out that X equals to 16 over 2, that is 8 units in its length. X equals to 8 units in its length, so here PB equals to X and X equals to 8. Likewise, BM also equals to X and X equals to 8. Here, CM, MC equals to 14 minus X. 14 minus X is 14 minus 8, that is 6. So MC equals to 6. QC also equals to 14 minus X, that is 6. In the next step, we join points A and O together by straight line. By joining points A and O, we can do those two right angles. We have the upper right angle AOP and the lower right angle OQA. What is the area of this big quadrilateral APOQ? The area of this big quadrilateral APOQ must be equal to the sum of the areas of those two components that it consists of. This is to say, the area of the big quadrilateral APOQ equals to the area of this first component that it consists of. This is the area of this right triangle APO plus the area of the second component that it consists of. This is the area of this right lower triangle AOQ. And again, if you remember that according to the first method of calculation, the area of the big quadrilateral APOQ equals to the first component that it consists of. This is the area of the upper right triangle APO plus the area of the second component that quadrilateral APO consists of. This is the area of the right lower triangle AOQ. What is the area of triangle APO? The right triangle APO. The area of this right upper triangle APO equals to the base AP is equals to 16 plus 8, that is 24, times the height PO, that is R02. So total, if you know that they have this upper right triangle APO equals to 24 times R02, 24 R02. The area of the upper right triangle APO equals to 24 R02. Likewise, plus they have the second component that for the other APO consists of. The second component is this triangle AOQ. And there this triangle AOQ equals to AQ, that is 18 plus 6, that is 24, times the height R over 2. So total, the area of this triangle AOQ also equals to 24 R over 2. There is the second component, that's called the other AOQ, APOQ consists of, is also equals to 24 R over 2. 24 R over 2 is 12 R, so we have 12 R plus 12 R is 24 R. So according to the first method of calculation, they have this big quadrilateral, the area of this big quadrilateral APOQ is equal to 24 R squared in size. In the next step, I deleted this straight line I deleted this straight line AO, and then you join points O and M together with a straight line. Point M is the point of tendency BC with this circle. So point O is the center of this circle, point M is the point of the circle itself, therefore OM is the radius of this circle, that is equals to R. The radius of M is equals to R, the radius of M is going to point M, that is the point of tendency BC with this circle. Whenever your radius is going to the point of tendency, then BC will be perpendicular to the radius MO. If BC is perpendicular to MO, it means that this circle equals to 90 degrees, and this circle also equals to 90 degrees, according to rule 1. The next step, we join points on B together with a straight line, and join points on C together with a straight line. When doing those constructions, you can do those 4 right triangles, 1, 2, 3, 4. The next step, calculate the area of each of those right triangles separately, and then get the areas together. Now this first right triangle or PB equals to the base PB, that is 8, times the height PO, that is R over 2. So total the area of this triangle or PB equals to 8 R over 2, that is 8 R over 2 is 4 R. What is the area of this right triangle OMB? The area of this right triangle OMB equals to the base BM, that is X, times the height MO, that is R over 2. So total the area of this right triangle OBM equals to 8 R over 2. 8 R over 2 is also 4 R. What is the area of this triangle the right triangle OMC? It equals to the base MC, that is 6, times the height MO, that is R over 2. So total the area of this triangle OMC equals to 6 R over 2. 6 R over 2 is 3 R. Likewise, what is the area of this right triangle OQC? This right triangle OQC equals to the base QC times the height QO, that is R over 2. So in total the area of this triangle OQC equals to 6 R over 2. 6 R over 2 is also 3 R. So in total we found out that the sum of the areas of those 4 right triangles is equal to 4R plus 4R, that is 8R. 8R plus 3R is 11R, and 11R plus 3R is a 14R. So total the sum of the areas of those 4 right triangles is equal to 14R square units in its sizes. And therefore the area of this big quadrilateral APOQ according to the second method of calculation must be equal to the sum of the areas of those 4 right triangles, that's roughly 14R, plus the area of this grand triangle ABC. And again, the area of this big quadrilateral APOQ according to the second method of calculation is equal to the area of this, the sum of the areas of those 4 right triangles, that's actually 14R, plus the area of this grand triangle ABC. So it is 14R plus the area of the grand triangle ABC. What is the area of this grand triangle ABC? Actually, use a special formula in order to find out the area of this grand triangle ABC. Here we have triangle ABC could be any triangle. So the area of triangle ABC that could be any triangle is as follows. It is equal to the square root of S times S minus 3 times S minus 3 times S minus 3. S is the semi-perimeter of the triangle, that is area that we are looking for. What is the semi-perimeter? The semi-perimeter is the perimeter over 2. The perimeter of one triangle equals to the sum of its 3 side lengths. In our case, the 3 side lengths is, we have 16 plus 14 plus 18. The perimeter of the grand triangle is equals to 16 plus 14 plus 18. 16 plus 14 is 30, 30 plus 18 is 48. So if we divide the perimeter 48 by 2, we get the semi-perimeter that is 24. So those two sides of the equation are equal to each other. So in total, if you all know that the semi-perimeter of this triangle ABC is equal to 24 units in its length. In this equation, A, B, and C are the side depths of the triangle that is area we are looking for. In our case, AB is 16, so we choose A is 16, BC is 18, and BC is 14, so we choose B is 14. Finally, CA is 18, so we choose C as 18. So again, our grand triangle ABC, A equals to 16 according to our choice, then B equals to 14, and C equals to 18, and the semi-perimeter S is 24. So we have all the data that is needed in order to find out the area of this grand triangle ABC. We just have to put the data inside this general formula for the area of grand triangle. This way we find out the area of our grand triangle ABC. We did it, and we found out that the area of our grand triangle ABC is equal to the square root of S. S is 24 times S minus A. S minus A is 24 on 16 times S minus B. S minus B is 24 minus 14 times S minus C. S minus C is 24 minus 18. So total, we should find out that the area of this grand triangle ABC is equal to the square root of 24 times 24 minus 16 times 24 minus 14 times 24 minus 18. So the area of this grand triangle ABC total it is equal to the square root of 24 times 24 minus 16. 24 minus 16 is 8 times 24 minus 14. 24 minus 14 is 10 times 24 minus 18. 24 minus 18 is 6. So in total, the area of this grand triangle ABC is equal to the square root of 24 times 8 times 10 times 6. Actually, the value of this expression in total is equal to 110.33 square root inside. So if you found out that the area of this grand triangle ABC is equal to 110.33 square root in size. And therefore, according to the second order of calculation, the area of this big quadrangle APOQ is equal to 14R, that is the sum of the areas of those four right triangles, plus the area of this triangle ABC is equal to 110.33 square root in size. And again, if you found out that according to the second order of calculation, the area of the big quadrangle APOQ equals to 14R plus 110.33. This is according to the second method of calculation. While according to the first method of calculation, we only found out that the area of the big quadrangle APOQ equals to 24R. So we have two different equations for the area of the same quadrangle APOQ. Therefore, we get the equation 3 that says that the area of quadrangle APOQ according to the first method of calculation must be equal to the area of the same quadrangle APOQ according to the second method of calculation. The area of the big triangle and the area of the big quadrangle APOQ, the area of the big quadrangle APOQ according to the first method of calculation equals to 24R. It must be equal to the area of the same quadrangle APOQ according to the second method of calculation. This is equals to 14R plus 107.33. So total, if we found out that according to equation 3, 24R equals to 14R plus 107.33. Here we subtract this 14R from this equation. So here we have 24R minus 24R minus 14R is 10R. 14R minus 14R is 0. So we have to only 107.33. Or 10R equals to 107.33. Here we divided this equation by 12, and we know that the radius R of this circle, that is the radius that we are looking for this equation, is equal to 107.33 over 10. This is actually 10.753 units in itself. Okay, again, the radius of this circle is equal to 10.733 units in its length. So we finish to repeat on the first solution of the first question, and the next time I repeat on the solution of the second question. In the second question, our task is to find out the area of this green shape. So in the drawing, we have three semicircles. This is the biggest semicircle, this is the medium semicircle, this is the medium semicircle, and this is the smallest semicircle. In addition, we have this rectangle. According to what is given in this equation, the area of this rectangle is equal to 4 square units in size. And finally, we have this quarter circle. Again, our test is to find out the area of this ring shape. So first of all, we define the length of this rectangle, this side is x, and the width of this rectangle is y. The length times the width is of course the area of this rectangle. That is to say, x times y equals to 4. X times y equals to 4. The opposite sides of the rectangle are equal to each other. Those two sides are equal to each other. But this side is y, and the opposite side here must be also equal to y. Those two sides are the area of this quarter circle, and therefore they are equal to each other in their lengths. So the radius here is y, so the radius here is also y. The problem here with the boring itself, that those two line segments must be equal to each other in their lengths. Okay, the problem is with the boring. So what is the diameter of this biggest semicircle? The diameter is x plus y, therefore the radius is x plus y over 2. So the radius of the biggest semicircle is equal to x plus y over 2 units in its length. The radius of the biggest semicircle is equal to x plus y over 2 units in its length. Likewise, the radius of this medium semicircle is equal to the diameter x over 2. That is to say it is x over 2. And finally, the radius of this smallest semicircle is equal to the diameter y over 2. And now if you found out that the radius of the biggest semicircle is equal to x plus y over 2 units in its length, the radius of the medium semicircle is equal to x over 2 units in its length, and finally the radius of the smallest semicircle is equal to y over 2 units in its length. Our test is to find out the area of this ring shape. So what is the area of this ring shape? From the drawing it is very easy to see that the area of this ring shape in total is equal to the area of the biggest semicircle minus the area of this medium semicircle minus the area of this smallest semicircle. Repeat again, the area of this ring shape is equal to the area of the biggest semicircle minus the area of the medium semicircle minus the area of the smallest semicircle. The radius of the biggest semicircle is x plus y over 2, the radius of the medium semicircle is x over 2, and the radius of the smallest semicircle is equal to y over 2. Units in its length. So the area of the ring shape equals to the value of this expression. What is the area of this biggest semicircle? Actually, the area of any semicircle equals to pi times the radius of the semicircle squared over 2. Therefore, the area of this semicircle must be equal to pi over 2 times the radius of this semicircle squared. That is to say, it is x plus y over 2 squared. So total the area of this semicircle is equal to pi over 2 times x plus y over 2 squared minus the area of this semicircle, medium semicircle. So the area of this medium semicircle equals to pi over 2 times the radius of this semicircle squared. The radius of this semicircle squared is x over 2 squared. So total the area of this semicircle is equal to pi over 2 times x over 2 squared minus the area of the smallest semicircle is equal to pi over 2 times the radius of this semicircle squared. This is to say it is y over 2 squared. So total the area of this small semicircle is equal to pi over 2 times y over 2 squared. So in the next step we just simplified those three expressions. In this way we found out the area of the ring shape. Here we have pi over 2 and x plus y over 2 squared is equal to x plus y squared over 2 squared, that is 4. So in total this expression equals to pi over 2 times x plus y squared over 4. Here we have minus pi over 2 and x over 2 squared is x squared over 4. Here we have minus pi over 2 times y over 2 squared. Y over 2 squared equals to y squared over 4. So total the value of this expression is equal to pi over 2 times y squared over 4. Here we have 8 in the denominator, and we have also 8 in the denominator of those two expressions. So we took 8 as a common factor out of those three expressions. So in the denominator we have 8 as a common factor, while in the denominator of this expression we have pi times x plus y squared. In the amount of this expression we have minus pi x squared. In the amount of this expression we have minus pi y squared. So here we have pi times x plus y squared. Pi times x plus y squared equals to pi times x plus y squared. X plus y squared equals to x squared plus y squared plus 2 times x times y minus pi x squared minus pi y squared divided by 8. Here we open the brackets of this expression. So here we have pi x squared plus pi y squared plus 2 pi xy minus pi x squared minus pi y squared. After open the brackets, we're left only with pi x squared plus pi y squared plus 2 pi xy minus pi x squared minus pi y squared divided by 8. Pi x squared minus pi x squared is 0. Pi y squared minus pi y squared is 0. So we're left only with 2 pi xy in the numerator divided by 8. We have to, we divided both the numerator and the denominator of this expression by 2. Again, we divided both the numerator and the denominator of this expression by 2. 2 over 2 is 1, so we left only with pi x squared, with pi xy in the numerator, and we have 8 over 2 is 4. So total we found out that the area of the green shape equals to pi times xy over 4. So it is pi over 4 times xy. Xy is 4, so we substitute xy by 4. You substitute xy by 4, and found out that the area of the green shape, that is the area that we are looking for in this question, is equals to pi times 4 over 4. So we have 4 in the numerator, 4 in the denominator, so 4 will get cancelled, and we left only with pi. So in total, we should found out that the area that we are looking for in this question, that is the area of this green shape, is equal to pi, it's correct in size. Okay, thank you very much.